Hi again. Uh, in the last tutorial, we discussed that fine tuning for a given particular problem was not the best thing that we could do. And then I said that in this particular scenarios where we have curated inputs and curated outputs, or if there is a particular set of documents that is not available in your LLM trainings, or particular information was available only after the training was done, this LLM will never know, right? And in this particular scenarios, we said that we can use something called as RAG architecture, or RAG. RAG stands for Retrieval Augmented Generation model or architecture. Basically, that's getting quite famous, in especially in enterprises. And today we are going to talk more about, not just talk, but I'll demo out the RAG architecture with LLM to get an appropriate response. Uh, Before I talk, or let me go through some introduction, and then maybe I'll show you some of the screenshots that I have taken from MongoDB conference, and then we will start with our demo. So first, let me talk about prompt engineering. I'm pretty sure that you all guys know what prompt engineering is, using our natural language to instruct LLMs to get the best output, right? So how do we format it? How do we ask? There has been quite a lot of research going on around prompt engineering, right? There is a lot about it. I mean, there is a dedicated wiki page about it. Please go through. But what I wanted to emphasize here is about zero shot, one shot, or few shot learning. So zero shot basically is just a straightforward question. Um, what do you mean by this? Or how much stars are there in the universe? And you just ask a plain question. One shot means you just give him one example, and then a question, and then basically you get answer. And few shot is nothing but you give few examples, uh, and then followed up by question, and tell him to refer to the given examples, and LLM will give an appropriate answer to it. It has been shown that by one shot or few shot technique, the improvement is drastic with the accuracy of LLMs basically. Yeah, and this is exactly what we're gonna use in retrieval augmented generation. That means we are going to have a set of data, maybe set of question answers, set of articles, set of knowledge base. It can be a textbook, it can be rules, it can be some penal codes, some tax instructions. It can be anything within organization, outside organization, public area. And then you retrieve the appropriate data that is required for your given question. And this is exactly the whole core of RAG architecture is embedded in. There has been a lot of work happening on semantic search. We'll cover that one. And then of course, once you retrieve the chunk of the data, you take that data, take your question, give it to language model, large language model, or our engine, AI engine, and then it will give you an appropriate prompt. So that's what we would be doing in our article. Maybe I just want to show you some of these screenshots that I have taken from uh, you know MongoDB conference, and that's truly worth showing it to you. Uh, this guy is Benjamin Flask is his name, I believe. Yeah, Benjamin Flask, and that's his introductory session. It's a 38-minute session. It's worth going through. I'll post a link also at later point of time. And then here he says, why do we need vector search? Um, uh, we are going to use MongoDB for doing our vector search. And then he talks about architecture, how it works, how does the relations of the embedded text is formed, how does the distance calculation is done, and things like that. And then what does vector databases normally do in the databases, how does it semantically form the similar data clusters and things like that. He also talks about evolutions of machine learning, but I think this is not very interesting for us in today's topic. And the architecture, how we're gonna do, we're gonna take a query from client, then we're gonna encode it using some embedding model. There are multiple of them, but we are going to use just one of them. And then you write with vector into the database, and we do a vector search using particular techniques. And then once we get the data, we're going to basically present it to a client. He shows it how it is done without vector search. Basically, you take a question, you make a prompt, you give it to LLM, we get the response and just give it back to the client. But using semantic search, this is what we're going to do. We're going to take a question, we're going to search in the database, we get the appropriate examples from our semantic search or vector database, and then with our question and the examples, we're going to give it to LLM, and then of course LLM is going to give us better answers. We take the answers and give it back to our client. So I think this is the diagram. You have to keep it in your mind throughout. We're gonna do step by step, not one-on-one, but this is exactly what we're gonna do. We're gonna take a question, we're gonna take that question and search with semantic search or vector search in the vector database. We get one or two depending upon how we want the paragraph or documents, and then give it to LLM. We're gonna get the response and then give the response back to our client. Let's see. Okay, so we're gonna take the data, we're gonna clean the data, we're gonna chunk the data, we're gonna create embeddings for semantic search, we're gonna store the data, we're gonna create the indexes for vectors, and then we're gonna have a nice prompt generated. We're gonna format the prompt, give it to LLM, and get the response back. Okay, so let's go ahead. We're gonna just import some standard libraries. You know what this .env is basically. I have stored MongoDB server connection into environment, and then this I'm just loading the .env file. So okay, here are examples. Here are basically two functions I'm going to use from OpenAI library. One is to generate embedding, and one is to get a response from LLM with RAG and without RAG. Um, Maybe you want me to talk more about embedding here. Uh, Let me first show you what do you mean by embedding. So embedding is nothing but representation of any data for that matter. If it is a text, if it is image, if it is a video, anything in form of vectors. Um, what do you mean by vectors? Let's go back to our example that has been shown in MongoDB. This is, uh, I think, good concept to understand. So let's say there are just two dimensions, or there are multiple dimensions, but for understanding, let's take two dimensions. And let's say, where do we plot man, woman, queen, and king, which has been shown on particular uh, picture here or diagram here. And then we say whenever there is a man, woman is again quite close to it, right? Or maybe from a different angle perspective, we say whenever we say man, king is closer to it. But if you say man and king are related, that means then woman and most likely the queen are going to be related. So whenever we are going to search for man, and if there is another document where the king is written, I think we're going to get king as well, as retrieved from the database. Whenever we're going to search woman, most likely we're going to get queen. I mean, the representation can be different ways. For example, whenever we say man, we want woman to be retrieved, and then we say, okay, if I write a king, then most likely it's gonna, with high probability, give me a queen as my word back. It all depends upon how are we going to create your embeddings and how are we going to create our distance measuring functions. There are multiple, at least 3 different functions. We'll see in our example there. Okay, so let's go back to our example. Okay, just I wanted to show you how does it look like. For example, I want to do a print generate embedding of Jupyter notebook is great. Yeah, or it's just array of 1536 real numbers between -1 and +1, if I'm not wrong. Yeah, and this is each number is representation of the whole string on one vector between -1 and +1, and there are total 1536 vectors or dimensions. There would be absolutely a different talk, more than half an hour talk or more than an hour talk, just talking about what are embeddings. So let me not get too much into details, but one core thing is that vector databases are getting quite a popularity because it is much uh, better to retrieve semantic search or same meaning search as compared to keyword searches or just wildcard searches. And the whole world is talking about vector databases nowadays. So let's not talk too much about um, how it is done, but rather than let's use it for our use case. Okay, so here I just took 2 random Wikipedia page. I could have gone for anything else, but I think this one will just give you a rough idea how we're gonna store the databases, store it into database, create a vector against it, and how syntactically or semantically we're gonna search for it. Okay, just 2 documents. Um, Here are those 2. If you see, I have just copied the description of the topic. um, I kind of cleaned it. So for example, all the suffixes, what is it called as, I don't know, all the numbers that are not relevant, I've just deleted it, I cleaned it, and then these 2 became my documents. It's 2 documents that I will be inserting it into my database. I'm not just going to insert it, but I'll pass this whole article and create an embedding against this particular article. And then I'll be storing title, article, and its embedding, all these 3 together as one document in MongoDB database. I think this is the most important. So using my function called as generate embedding, I'm just going to create one more uh, dictionary article. What is it? Uh, one more tag. One more. I don't know what is that in my document. and then I'll insert it. So let me execute this one. Yeah. So let me just show it to you. How does this looks like? It will be too long, but I want to show you that uh, the embeddings are created. So it's going to be a title, article, and embedding for the complete text. So this whole representation of text is converted into vector representation or embedding representation. If you see, the length of this particular thing is going to be 1536. Okay, and then I'm just going to insert it into database, my MongoDB database, and this is just a confirmation that it was really inserted. Okay, this is my part one. Now all my data is available with its vector representation into the database. Now let's go to the database and do some important activity that is required. Um, One of the most activity that we will have to do on database is to create an index, so that whenever we want to search the database, we are not going to search on the text, but we are going to search on the vector representation. And this search, or any search for that matter, is always done on index. So we want to create an index for a vector. So let's do that. I go to my database. Let me go to search, or let me show first the data that was inserted. Okay, Wikipedia articles. So this is my database name, this is my collection name. uh, I mean, if you don't know what MongoDB is, maybe that is an entirely different, again, hundreds of videos out there. Please refer to one of them. But to our use case, I just want to walk you through um, the at last database uh, storage. And if you see, here is my one document, and here is my second document, basically. Yeah. Okay. So my collection is here. Let's go to index creation, and in whole of this video, this is the most crucial part. If there is a mistake, there is a very rare chance that you will be able to find where you're doing a mistake, because error handling, you don't really get an errors which are quite meaningful. So maybe you just want to not do a mistake here. So go ahead and say create index. We can do it in a visual editor, but we will not be able to represent it in a very nice format. So let's go to JSON editor so that we can have more control of what we're going to do and what we are not going to do. And here, because there is a very high chances that I'm going to make mistake, therefore what I did was I did some homework and just created it beforehand so that I don't do any typos. Okay, name of the index, give whatever index that name you want to do. It can be default. I just wanted it to be a little bit unique so that I can show it to you uh, while execution. And then this is an index. Maybe very quickly, I don't know what does dynamic true stands for. It was their default. I really did not go through it, but for I think every index out there, it's dynamic is equal to true. I'm so sorry for not knowing that one. And then of course the field representation. This is the name of our field, um, which stores the vector representation. And then what is its dimension? And I said that it's 1536 vectors basically. Similarity is how the search should be done. So there are three possible values. One is dot product, the other one is cosine, and third one is third one is Euclidean. Yeah, third one is Euclidean. Um, each one has a different use case. I think if it is a pixel to pixel match, if you want to search for images, similar images, I think Euclidean is used. I don't know. Please excuse me. But for text similarity, uh, dot product is the best form of search. And then what kind of uh, vector it is? It's a KNN, uh, nearest neighbor vector search. It is. We're gonna do it on Wikipedia DB and articles collection. And then I say just create an index for me. It normally takes few seconds to few minutes depending upon how big your database is. Again, hardly 30 seconds it should be, but uh, and this is the magic of MongoDB, that creation of, once you create an index, you know, running it, keeping it up to date is all done by MongoDB. Before we go back to our demo, I just want to tell you, um, for example, any version below 7.0.2 on version 7 and any version below 6.0.11 does not support vector search. So please keep it in mind. I tried that and I failed every time. So for example, I do have 6.0.11 version database. Uh, this is a free database. I tried vector search on this one. Somehow it didn't work. And therefore I created a dedicated cluster, and it worked on it when I tried it before. So I highly encourage you then to at least ask MongoDB why it is not working on a free database, or maybe I'm doing something wrong, or please go ahead and create an dedicated database if you want vector search to be working. Okay, let's go ahead and see if the index is created. Yeah, so we had two articles, 100% index is done, and our index is quite active. Super. So this part is done, and now we just gonna uh, retrieve the documents from the database and then give it to our LLMs. Okay. So yeah, let's go to this one. So user is gonna ask me why computers are costly. So if you look at our documents, um, nothing talks about computers are costly, right? So for example, this talks about New Zealand general elections, and this talks about global chips shortage. So semantically, if you see, computers are most likely costly because there was a chip shortage. Um, in this whole article, there is nowhere word called as costly or computers, right? And that's the whole magic of semantic search. So let's go ahead and use vector search aggregate function. This is again, as I said, as I told you, this particular function will work only on the databases that are 6.0.11 and higher, or 7.0.2 and higher. There are other databases also, for example, um, cognitive search in Microsoft Azure is kind of trying to provide a very similar capabilities. There is a ChromaDB who is trying to provide the very similar uh, functionalities, and there are hundreds of others, I'm pretty sure. But as I said, I thought MongoDB was quite a leader in this one. They have put in a lot of efforts. I've seen the results, and that's why I wanted to show it to you now. And I'm pretty sure after 1 month the answer will change, and after 3 months there would be another answer for that. And then query is, we just cannot query for this particular word. We also have to convert this one into embedding representation or vector representation, and then there is going to be a search of vector against vectors, right? And this search is going to be in the form of, as I said, a dot product. Um, Path is the field on which we're going to search. Again, number of candidates, I don't know what this is all about. I did not change the number here. Limit is the number of documents that I'm gonna get back, and index is basically the name of the index that I'll be using for my vector search. So there can be multiple indexes. You can use any one of them, but for our purpose, I have just created one index. So let's see what, I mean, it's quite obvious for me that when I search from the database, I should get this article rather than this article. Moment of truth. Oh, oops, sorry. So this is my query. And why I did that? Basically, this result is an MongoDB result, and there is a very high possibility that I will lose it or I'll not be able to put it in a right format. So I just converted everything into a list of strings basically, so that, and then in this variable I use it anywhere. So yeah, as expected, no surprises there, but beautifully we got the result that we wanted. And now we're going to give this generated or retrieved response for uh, for generation. But we are not just going to give as is. We'll have to just tell something to our LLM, right? And that's how we have, let's say, prompt engineered our text. So here we say that, okay, this is the use query from the user. Please use the context um, given below to answer it appropriately. And then I'm going to give the result that I have retrieved from the database. Okay. It's not defined. Oh, see. Okay. And let's see. Okay, so now see, he used the context, he used the paragraph and a question to generate appropriate answer. So the computers are costly due to global chip shortage, blah, 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 blah. So quite a strong, quite an appropriate answer, just because we had context given to it. I believe that made a lot of sense to you. This is nothing but, instead of having 4 lines, 5 lines of code, I just put it into one single line. Yeah, yeah, nothing else. So that it's a condensed code which you can use it for using it in your code. I hope you were able to take some things from the whole tutorial. As always, if you have any questions, queries, suggestions, please do come back to me. I'll be more than happy to discuss with you all. Thank you so much. Ciao.